Hello everyone, welcome back to my YouTube channel Physics Nexus by Sajjad Ali. Today I will try to explain magnetism. Okay, alright. Why do we study magnetism? Okay, we do study magnetism because it is one of the fundamental force of nature, number one. Okay, number two, we need to study magnetism to understand the natural phenomena like why earth just like behave as a very huge magnet, number two. Number three, we do need to study magnetism to learn how electricity and magnetism are interrelated. How can we produce electricity by using magnetism, and how can we produce magnetism by using electricity? We also need to study magnetism to understand medical technologies like how the MRI scanners work, how the generator, how the other type of machines, how the microphone, how other devices work. Okay, what is mean by magnetism? Magnetism is the study about magnet and its properties. Okay, as we know that magnetism is the force, okay, force of attraction or repulsion between different types of magnets, different types of magnetic materials. Okay, like magnetic material means like iron, cobalt, steel, etc. Okay, there are large number of magnetic materials. Okay, on the basis of magnetism, okay, there are different types of magnetic material. Some magnetic materials have strong magnetism and some magnetic material has weak magnetism. Okay, first of all, what is mean by magnet? How can we define magnet? Okay, magnet means any substance या any material which has considerable magnetic field around it. Okay, what is magnet? Magnet is a substance which has considerable magnetic field around it. Okay, due to which this substance attract or repel other magnets या other magnetic material. Okay, what is magnet? All right, magnet means any substance या any material which has considerable magnetic field around it. Magnetic field around it called magnet. Okay, what is magnet? Magnet means any substance which has some considerable magnetic field around it. Okay, there are many types of, for example, there are many types of magnetic materials like iron, nickel, cobalt, steel, etc. Okay, what are the some properties of magnets? Okay, how magnets are behaving? Okay, when what are the some properties of magnets? As we know that magnet has two poles. Okay, every magnet, okay, either it will be very tiny magnet or either it will be very huge magnet. Okay, every magnet must possess two poles. Number one, every magnet has two poles, north pole and south pole, north pole and south pole. Like if we have a bar magnet, okay, like if we have a bar magnet, okay, as we know that bar magnet has two poles, one pole is the north pole, another pole is the south pole. So any magnetic material must have poles. Okay, as we also know that no magnet, okay, exists in the form of single pole, no monopole exists in nature. Okay, हमारे पास नेचर में कोई मोनोपोल एग्जिस्ट नहीं करता. मैग्नेट ऑलवेज एग्जिस्ट इन द फॉर्म ऑफ डाइपोल. ओके, मैग्नेट हमेशा डाइपोल में या दो पोल्स में एग्जिस्ट करेगा, चाहे हम मैग्नेट को क्या करें, कट करें, जितना भी छोटा करें. ओके, अगर एटॉमिक लेवल तक भी अगर हम मैग्नेट को क्या करेंगे, कट करेंगे, फिर भी हमें सिंगल पोल में मैग्नेट नहीं मिलेगा. ओके, क्यों नहीं मिलेगा? जस्ट थिंक अबाउट इट. ओके, नंबर 2. Okay, as we know that The second property of magnet is north pole and north pole. For example, suppose if we have two bar magnet, okay, if we have two bar magnet like this is also a north pole, this is south pole, okay. As we know that like poles repel each others, okay, like poles repel each others, like poles repel each others, and unlike poles attract each other, okay. Unlike poles attract each others. That's why we can say that, okay, magnetic is a force of attraction or repulsion. If we have two like poles, then the magnetic force is repulsive, okay. If we have two poles which are unlike poles or opposite poles, then the magnetic force between the two poles, or between the two magnet, or between the two material must be repulsive, must be attractive, okay. All right. Number 3, okay, what is the third property of a magnet? Okay, as we know that magnetic field lines, okay, as we know that magnetic field lines always start from the north pole. Magnetic field lines always start from north pole and end in south pole. Magnetic field lines start from north pole and end in south pole. Okay, all right. Suppose if we have a magnet, okay, how can we represent the magnetic field? Okay, how can we know about, for example, some magnet attract other magnet? Okay, because every magnet has some magnetic field. Okay, what is meant by magnetic field? Magnetic field means it is the region, it is the space around the magnet. Okay, all right. Now I will explain what is meant by magnetic field. Okay, what is meant by magnetic field? Magnetic field. Now I will explain what is meant by magnetic field. Okay, magnetic field is the region around the magnet where other magnet experience magnetic force. Okay, if we have a magnet, for example, this is just like a magnetic material. Okay, so what is meant by magnetic field? Okay, if we have a huge magnet or source magnet, okay, अगर हमारे पास क्या है, एक बड़ा मैग्नेट है, एक सोर्स मैग्नेट है, अगर हम एक टेस्ट मैग्नेट को क्या करेंगे, इसके करीब ले आएंगे. दिस इज अ टेस्ट मैग्नेट जस्ट लाइक अ कंपास नीडल. दिस इज स्मॉल मैग्नेट और टेस्ट मैग्नेट जस्ट लाइक अ कंपास नीडल. ओके, तो हमारे पास जो बड़ा मैग्नेट है इसके इर्द गिर्द क्या होगा, एक रीजन होगा. ओके, what is magnetic field? Magnetic field is the region around the magnet where other magnetic material experience magnetic force. Okay, what is magnetic field? Magnetic field is the region around the magnet where other magnet experiences magnetic force. Magnetic force. So if we have a source magnet, okay, what is meant by magnetic field? Magnetic field is the region, the space around the magnet where other magnet or small magnet or test magnet must experience magnetic force. Okay, now for example, how can we represent magnetic field? As we know that magnetic field is a 3-dimension space, it is a 3-dimension region. Okay, so how can we represent magnetic field? We can represent magnetic field by using an imaginary lines which are called magnetic field lines. Okay, for example, if we have a magnet, okay, which has considerable magnetic field around it, okay, then how can we represent magnetic field? We can represent magnetic field by using magnetic field lines which are called imaginary lines. Okay, these are the imaginary lines just like this. Okay, So what is meant by magnetic field lines? Magnetic field lines are the imaginary lines which we use to represent magnetic field around the magnet. Okay. Okay, all right. Suppose if we have a bar magnet, okay, then how can we represent magnetic field for a bar magnet? Then how can we represent magnetic field lines for a bar magnet? Suppose we have a bar magnet. As we know that bar magnet is a permanent magnet, okay, which is strongly magnetized, okay. As we know that any type of magnet has two poles, for example, north pole and south pole. Now, how can we represent magnetic field lines for a single magnet, single bar magnet, okay? As we know that magnetic field lines always start from the north pole and end in south pole, okay. That's why we can represent magnetic field lines just like this, okay. Start from the north pole and end in south pole, okay, just like this, okay. End, start, end, start from the north pole, end in south pole, just like this, start, end, start from the, okay. This is the magnetic field, okay. This is the magnetic field lines for a bar magnet, okay. Magnetic field lines always start from the north pole, just like this, and end in the south pole. So, okay, this is the magnetic field representation for a bar magnet, okay. Now how can we, for example, find out the magnetic field strength or intensity, okay. We can find out the magnetic field intensity by using magnetic field lines, okay. If the magnetic field lines are very uniform and very close to each other, it means that the magnetic field intensity is very strong, okay. At poles the magnetic field strength is strong. For example, at poles magnetic field strength B is strong. Region, for outer region, yeah, from out of the poles, okay, the magnetic field lines are not equidistant, the magnetic field lines are not uniform, and the magnetic field lines are not very close. That's why magnetic field at outer side, the outer region is negligibly, as compared to the poles, weak, okay, weak. So at poles, magnetic field is strong. Why the magnetic field is strong? Why the magnetic field intensity is strong at poles? Because the magnetic field lines are very close to each other and uniform. Okay, and out of the poles, yeah, in outer region, the magnetic field lines are not uniform, or the magnetic field lines are not very close. That's why magnetic field intensity is weak. Okay, all right. Now, if we have two magnets, okay, suppose if we have two bar magnets, then how can we represent the magnetic field lines for two bar magnet? Okay, it can depend. If, for example, if we have two magnets, okay, which have, for example, two same poles, okay. For example, if we have two magnets like this, if we have two magnets, one is north, another is south, okay. This is again south and north. How can we represent magnetic field lines for two bar magnets? Okay, we can easily find out the magnetic field. Yeah, we can easily draw the magnetic field lines for two bar magnet, just like this. As we know that magnetic field lines from start from the north pole and end in the south pole. Okay, these are the two opposite poles. That's why, okay, these two magnets attract each other. Okay, just like this. Okay, and for outside, start from the north pole, end in south pole. Okay, Okay. How can we represent magnetic field lines for two bar magnet? Okay, we can represent two magnet. We can represent the magnetic field lines for two bar magnet just like this. Okay. All right. Now, how can we represent magnetic field lines for two bar magnets? Okay. As we know that north pole and south pole are unlike poles. That's why north pole and south pole attract each others. Okay. And the magnetic field lines inside, yeah, a pole is uniform and very close. That's why magnetic field intensity is very strong here. Okay. Outside the pole, yeah, in outer region, the magnetic field lines are not very close and non-uniform. That's why magnetic field intensity is weak. And this is the representation for two magnets if the poles are opposite. Okay. Now, how can we represent the magnetic field lines for two bar magnets if the poles are same? For example, this is also a south. Then what is happening there? Okay. If we have two bar magnets which have same pole, then how can we represent magnetic field line? Then we can represent magnetic field line just like this. Okay, magnetic field lines repel, 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 repel. Okay, this is the region where there will be no magnetic field intensity. Okay.